All right, welcome everyone. Grab out some scratch paper, get something to write with, and let's work on these together. Pause the video if you want to try the problem before I work them out for you. So here we've got this linear equation. We want to figure out x. So we're going to subtract 23x from both sides. So we have negative 3x equals negative 1776. And then we divide by negative 3. So the negatives will cancel. And we'll use our calculator because we're allowed to use our calculator for this. And we get x equals 592. So there's our answer to number 1. Number 2, determine the sum of this in simplified radical form. That's key, simplified radical form. We need to simplify these radicals. Now we can't take the square root of 32 and get an integer. So what we need to do is we need to break this into 16 times 2. And we need to break this, 2 is out front, 4 times 2. Because square root of 16 we can find. That's 4 square root of 2. Here we've got 2 square root of 2. So, whoops, the sum, my mistake. So that's 4 square root of 2 plus 4 square root of 2. Since they both have square roots of 2, we treat this like a variable, and they are like terms, so we get 8 square root of 2. All right. Number 3, determine the numerical coefficient of x to the 4th. Now, some people probably tried to multiply the whole thing out. And if you did, hats off to you. It works. But I want to show you a slightly easier way to think about it. If I want x to the 4th, and I'm multiplying with this, which term over here is going to do that? Only that one. So that means if I multiply those two, we get 21x to the 4th. Now, that's not the only way you can get x to the 4th. Because if I'm multiplying 5x, I can get x to the 4th by multiplying this. And when we do that, we get 10x to the 4th. And if I look at this third term, 4, if I want to get x to the 4th, I need a term with x to the 4th. I don't have it. So that means these are the only two terms that are going to be x to the 4th in this problem. So 31x to the 4th, and they only want the numerical coefficient. So this right here, 31x to the 4th, is actually not the answer. You're going to get that marked wrong. They only want the coefficient of 31. All right. Number 4. Here, this product is equal to Ka to the W, B to the P. Now, all these letters tend to mess people up. So what I suggest you do is just forget this for the moment. We'll come back to it. What we'll do instead is let's figure out this product. So we have 2 and we have 5. So when we multiply those, we get 10. Next, we'll multiply a and a squared. And when we do, that is a to the 3rd. Then we'll multiply b to the 3rd and b to the 5th. And when we do, that's b to the 8th. All right. So now what we've got is k. Let's change this right here. This number is k. This number right here is w. This number right here is p. So if I want k plus w plus p, that's going to be 10 plus 3 plus 8, which is 21. Number 5, let a railroad, I guess, b be the binary operator defined by this. We want to figure out the value of this whole operation. So what we're going to do is we're just going to focus on this right here. So 2, railroad 0. Okay, so if I follow the rules, A is the number in front, B is the number behind. So 2 times the number in front minus the number behind all over the number in front. So that's 4 over 2, which equals 2. All right, so here, now I do 2 railroad 6. So 2 times 2 minus the number in the back, which is 6, all over the number in front, which is 2. So 4 minus 6 over 2. So we get negative 2 over 2, which is negative 1. So now we need to take these two answers that we've come up with, and we need to calculate 2 railroad 1. So 2 times 2 minus negative 1 all over 2. So that's 4 plus 1 over 2, which gives us 5 halves. And there's our answer. Number 6, determine the square root of the sum of the first 5 smallest primes. So prime numbers. Now they don't start with 1, they start with 2. And then we have 3. Then we have 5. Then we have 7. Then we have 11. So then it says the sum of. So we're going to add these together. And when we do that, we get 28. But we're not done because we want the square root. So we have the square root of 28. Now notice the problem doesn't say anything about decimals. And when it doesn't say anything about decimals, we have to have exact simplified form. So kind of like number 2, we need to simplify this square root. So what we can do is we can break up 28 into 4 times 7. Square root of 4 is 2, leaving the 7 behind. So there is our simplified square root. Number 7, determine the sum of all the values that satisfy this equation. So what we're going to do is let's multiply this out. So we have 2x squared minus 5x minus 6x plus 15. And let's multiply out this side. X squared plus x minus 3x minus 3. And so we have 2x squared minus 11x plus 15 equals x squared minus 2x minus 3. So what we have is we have a quadratic. And like all good quadratics, especially with ones at this level, we want to get them equal to 0. So we're going to subtract x squared to the left side. We're going to add 2x to the left side. And we're going to add 3 to the left side. So when we do, we have x squared minus 9x plus 18 equals 0. Now, this we can factor into x minus 6 and x minus 3. So that means x minus 6 is equal to 0, or x minus 3 is equal to 0. So x is equal to 6, or x is equal to 3. And so we want the sum of all the values that make it true. So that's this and this. So we want 6 plus 3, and that is 9. That is our sum. Number 8, determine the number of square units in the area of this given figure. All right, let me blow this up a little bit. Now what we want to do to make this a little easier on ourselves is to break this into smaller bits. Now, this right here is 10, which means so is this. This from here to here is 10. Now this from here to here is 24, so that means from here to here is 14. Which means if I draw across here, this is also 14. All right. Now this length right here is 4, which means this is also 4. All right. Now, remember that this whole thing is 20, from here to here. So we've got 10, we've got 4 already accounted for, so that means this is 6. So this is 6. So now what we do is we find the area of each piece individually. So 24 times 10 is 240 here. 4 times 14, let's be sure of this. 4 times 14, I said 14, that's 56. All right, here, now let's remind ourselves that this right here is 6 times 4, so this is 24. Now, this whole length is 14, but this length right here is 4, which means this part of our triangle is only 10. So we have 10 times 6 is 60, but it's a triangle, so we multiply by 1/2, and so this is 30. So now we take 240 plus 56 plus 24 plus 30, and we get 350 as our area of this entire region. All right, number 9. Set of numbers is given to us. We want to determine the median of this set. Now, the easy way to determine the median is to cross off the largest and the smallest, and we repeat that until we're left with either 1 or 2. So biggest and smallest. We go again. Biggest and smallest. Go again. Biggest and smallest. Go again. Biggest and smallest. So now we're left with 2. When you have 2 numbers, what you have to do is you have to add them and divide by 2. Now, thankfully, they have a common denominator. So we have -1 over 10 all over 2, which is the same as multiplying by 1/2. So we get -1 over 20. All right, number 10. So here, this equals that. Now, the important thing here is that this equals that, and that this piece equals that. So I can write this as x equals 2y minus 4, and y equals 3x. So what we have is we have a system of equations, and we can substitute 3x in place of y. So x equals 2 times 3x minus 4. So x equals 6x minus 4. So when I subtract 6x, I get -5x equals -4. So we divide by -5. X equals 4/5. All right. Now we not only need x, but we also need y. But remember, because of this equation, y equals 3x, so 3 times 4/5 is going to equal 12/5. Now, what is it we want? We want the perimeter of this rectangle. So we're talking about a rectangle. Now, the perimeter is the length is 10x, and the width is y plus 13 over 5. Well, x is 4/5. So if I multiply 4/5 times 10, that's 4 over 5 times 10, we get 8. So this is 8. Then we have to take the width. We have to take 12/5 plus 13/5. So 12 over 5 plus 13 over 5 is 5. So we want the perimeter. So if this side is 8, then the other side is 8. If one width is 5, the other side is also 5. So that means that our total perimeter is 16 plus 10 is 26. Number 11. We want to determine the largest integral value of this inequality. So first we're going to solve it. So when we do, first we're going to multiply in the 4. So 19 minus x is going to be greater than 4x minus 19. So next we'll add x, and we'll add 19. So 38 is greater than 5x. So we divide by 5. So 38 divided by 5 is 7.6. Now if I turn this around, x is less than 7.6. So it's any number less than that, but we want the largest integer. So the largest integer that's less than 7.6 is going to equal 7. Number 12. A pollster reported that 78 people answered yes to his question, and the remainder answered no. 88% of the people answered no. Now that's important, because if 88% answered no, that means 12% answered yes. Now we want to determine the number of people in this poll. So if 12% makes 78, what we want is what's 100%. So we can set up a proportion like this, where we have percent on top and people on the bottom. So with a proportion, these two numbers we know, so we'll cross multiply these and divide by 12. So 78 times 100 divided by 12. And so x equals 650 people. Number 13. In Saudi Arabian currency, a rial and kurush are coins, where 1 rial is equivalent in value to 20 kurush. A person has a purse of 15 coins. So the number of rial and the number of kurush add up to 15. And the total value is 20 kurush. Now, remember that the rial is 20 times as valuable as the kurush. So the way we're going to write it is 20r plus q equals 205. So what we want is we want the number of rial coins in this purse. So what we have is we have a system of equations, and the easy way to do this one is to solve it. We take 20r minus r, and that equals 19r. We take 205 minus 15, we get 190. Now if I take q minus q, we're left with nothing. So now we're left with 10 is the number of rial coins. Now the important thing here is to remember to put the 20 here, because 20 are because the rial is 20 times as valuable. The mistake I made was to put the 20 on the q, which we're not doing. Whatever is the more valuable, that's what carries the 20. Number 14. So this line is parallel to this line, and it's perpendicular to this line. So we want to determine the product of KW. So first we need to figure out what is the slope of this line. So 2x plus 3y equals 8. So if we subtract 2x, we get 3y equals negative 2x plus 8. And then we divide by 3. So y equals negative 2/3 x plus 8/3. All right. So now we know that this line has to have a slope of negative 2/3. And this line down here has to have a slope of positive 3/2. All right. So now what we have to do is we have to do the same steps that we just did. And figure out what is k and what is w. So 12y equals negative kx plus 15. So now we divide by 12. So negative k over 12x plus 15 over 12. So now we can say that negative k over 12 equals negative 2/3. So when we cross multiply and divide, negative k is equal to negative 24. So k is equal to 8. Now, let's figure out what w is. So 6x plus wy equals 10. Subtract 6x. So wy equals negative 6x plus 10. And then we'll divide by w. So y is equal to negative 6 over w, x plus 10 over w. So now we know that this has to be a slope of 3/2 because perpendicular slopes are opposite and reciprocal. So this is negative, this is positive, and then we flip the fraction. So negative 6 over w equals 3 over 2. So negative 6 times 2 is negative 12, divided by 3 is negative 4. Now, what we want is we want the product kw. So kw equals 8 times negative 4, so that is negative 32. So there's our answer. Number 15, several pairs of prime numbers, each prime less than 100, are of the form n and 2n plus 1, where n is a positive integer. For such pairs, determine the greatest value of 3n plus 1. All right. So to figure this out, we're going to have to do a little bit of trial and error, guess and check. All right, so let's see, 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, and if we keep going, 41, 43. Notice I'm skipping the evens because I know the evens aren't prime after 2. I'm skipping all the multiples after 5. 41, 43, 45. I think 47 is prime. I could be wrong. Now I'm going to stop because I know that both these numbers and 2n plus 1 has to be less than 100. Okay. So now what I need to do is I need to start checking these numbers. Let's see, 47. I know it's not divisible by 3, and 47 is not divisible by 7, and it's definitely not divisible by 11, so I'm pretty sure we're good. So 47 times 2 plus 11 is 105. That is too big, so that's a no-go. So let's go down. 43 times 2 plus 1 is 87. Now it's an odd. The question is it prime? Well, let's divide it by 3. No, it's not. So that one's no good. So we got to go down again. Times 2 plus 1, 83. That looks like it has promise. 83 divided by 3. Nope. Definitely not by 5, by 7, by 11, by 13, by 17. Yeah, I think we're good. So this is the number. Now, we want to figure out the greatest value of 3n plus 1. So we want what would be 3n plus 1 in this situation. So 41 times 3 plus 1 is 124. And there's our answer. Number 16. A positive integer n is subtracted from its square. So that means its square is n squared, and we subtract it from n squared, and it gives a result of 42. So we want the value of n. So we have a quadratic again. So to get this quadratic in a way that we can solve it, we're going to subtract 42 to the left side. n squared minus n minus 42 equals 0. So this will factor into n minus 7 and n plus 6. So that means either n minus 7 is 0 or n plus 6 is 0. So n is equal to 7 or n is equal to negative 6. Key thing here, it says a positive integer. So that means that 7 is our answer, not negative 6. Yes, it's a solution to this, but it's not a positive integer. Number 17, landscapers Max and Tom, working together at their own rates, can mow a common subdivision, common area in 3 hours. So that means that Max and Tom can do a third of a job in 1 hour. Now, Max can mow at a constant rate 3 times as fast as Tom's constant rate. All right. So let's say M is Max's time to finish alone. And let's say T is Tom's time to finish alone. So, if Max can do the job in 2 hours, then he can do half the job in 1 hour. That's the idea. So what we do is we take 1 over m plus 1 over t. This is the fraction of the job that Max can do in an hour. This is the fraction of the job that Tom can do in an hour. And together, they can do 1/3 of the job in 1 hour. Why? Because together it takes them 3 hours. Now, it says that Max can mow at a constant rate 3 times as fast as Tom. So that means Tom's time is equal to 3 times Max's time, because Tom takes longer. So 1 over m plus 1 over 3m equals 1/3. So what we've got is we've got m, but it's in the denominator. So what we're going to do is we're going to multiply everything by 3m. Every term. And when we do that, we get 3m over m plus 3m over m equals 3m over 3. And when we simplify, we have 3 plus, whoops, I forgot something. 3m there, 3 plus 1 equals m. So, what does this mean? Max can finish the job alone in 4 hours. So Tom can finish the job in 12 hours. Now we can go actually attack the problem. It says 1 week, Max mows for an hour by himself. So that means 1/4 of the job is done. 3/4 is left. And then Tom joins him. So that means 3/4 of the job is left to do, and each of them, and working together, they can do 1/3 of the whole yard in 1 hour. So we take 3/4, how much is left to do, divide by how much they can do each in an hour. So 3/4 divided by 1/3. So 3/4 divided by 1/3, and we get 2.25 hours. Now we want it in the number of minutes. So that's times 60. So it takes 135 minutes to finish the rest of the job. So this is not counting the hour that Max mowed. Number 18, the decimal representation repeats in a block of k digits, where k is the least such possible positive integer. So determine the sum of these k digits. All right, so we take 2 over 13, we get 0.153846153 . So we have this block right here, we have this block here. So we want the sum of each of these digits. 1 plus 5 plus 3 plus 8 plus 4 plus 6. And we get 27 as the sum of those digits. Number 19, a typesetter of old used small blocks, each imprinted with a single digit to the number of pages of a book. Starting with 1, the typesetter used 4,425 for the digit blocks to number the pages of a book. So how many pages were numbered? So let's start from the bottom. 1 through 9, 1 block each. So that means 9 blocks total. So now we'll go to the 2 digits. So we have 2 blocks each. Now from 10 to 99, we're peeling off the 1 through 9. So that means it's 90 times 2 is 180 blocks total. That's 100 to 999. This is 3 blocks each. Now this is 900 times 3, so that's 2,700 blocks. So in all, we've got 9 plus 180 plus 2,700. So we have 2,889 already accounted for. So 4,425 minus 889. So this is how much is left. 1,536 left. And we have to divide that by 4 because now we're dealing with 2-digit numbers. And so we have 384. So how many pages? 1,383. Now it's a very subtle thing, but remember, we haven't counted 1,000. So that means we have to start with 1,000 and then go 1,001, 1,002. So that's why it's 1 less. And the last one, number 20. If a and b represent non-zero real numbers, we have this system of equations, then x equals ka plus wb. So what we want to do, what this is telling us is we want to cancel the y's. So I'm going to take the first equation and multiply it by 5. And I'm going to, whoops, that's 5a, not 59. And the second I'm going to multiply by 3. So 6x plus 15y equals 6b. So I'm going to take the bottom minus the top. So we have x equals 6b minus 5a. Now they want us to put the a first, so negative 5a plus 6b. So k equals negative 5, w equals 6. So k over w equals negative 5 over 6. And we can't simplify that fraction, so there's our final answer. Thanks for watching. If you see any mistakes, comment below. If you have any more requests of other ICTM problems, we will be working on other parts of this contest, so stay tuned.